Greetings of the day. Welcome to the course on Operations Research Technique. Right now we are in unit number 2, which deals with assignment and transportation models. And in the beginning of this particular unit, we have seen what is assignment problem, what are the practical applications where we can use assignment models for finding solutions to the given problem, maybe in the form of maximization or minimization of the given objective function. We have also seen mathematical formulation of the linear programming model, and we have on the point of starting of numerical, and we have discussed what are the various elements of the numerical, and now we will see how to solve the numerical based on Hungarian method. We have discussed various steps of Hungarian method, if you recall, in our last lecture, and now we will follow those steps in detail and we will arrive to a point where we will get optimal solution of given assignment problem. So now we'll start with problem, and before that I will just quickly go through what are the steps involved in Hungarian method. So if you recall, these are the various steps in Hungarian method, that is, develop the cost matrix from the given problem, perform row reduction. I will explain now how to perform row reduction, and if required in a matrix, then we have to perform column reduction. Then assignments in particular zero cost cell, and assigning zero cost to the various cells row wise and column wise, and testing whether the solution which we arrived at that point of time is optimal or not. If our solution is not optimal, then we have to move ahead, that is for improvement of the solution. And now here we will go through 7 steps. In that 7 steps, this 5th step is very crucial, wherein we have to follow all these sub steps. So I will explain all these sub steps in a coming problem. And now you can see with blue color I have written some. If the number of lines drawn or total assignments is equal to the number of rows, or we can say number of columns, then current solution is optimal. So these are the steps to draw minimum number of lines, covering all cross or assigned or unassigned zeros. If those minimum number of lines satisfy the condition that those lines are equal to number of rows or columns of a matrix, then our current solution which is under test is optimal. If you remember, the very first condition which is required for assignment problem is it has to be a square matrix. If matrix is non-square matrix, we have to make it square matrix by adding dummy row or dummy column as the condition may be. So first we will see whether the given matrix is square matrix or not. If it is not, we will make it square. Now see, this is the problem which we have discussed in last lecture. We have to assign these 4 subassemblies named, these are the names of the subassembly. Subassembly 1, 2, 3, 4 means 4 different subassemblies are available, and 4 contractors are available which can perform these tasks. Now it is given that these contractors, they have some different skills of doing the job, and these cost which is given in the matrix is in terms of hundreds of rupees. So in my last lecture I have explained that this 15 is 1500, 13 is 1300, 14 is 1400, that is 1400. Meaning of this is that if suppose I consider this 12 means 1200, if subassembly 2 is assigned to contractor number 2, the costing will be 1200 rupees. Like that, what we have to do through optimal OR is we have to assign these 4 subassemblies to these 4 contractors, so that what is the objective function as? You can read here, I will underline that. What is the requirement? so that minimize total cost. Means we have to minimize the total cost of assigning these sub-assemblies to the contractors. So the first step, very first step is we have to ensure that the given matrix is whether it is square matrix and or not. Now we can see second row, third row, fourth row, first column, second column, third column, fourth column. So it is actually 4 by 4 matrix. So that condition which we need to test is first is square matrix, that is satisfied. Now we will go with further aspect, that is performing row operation, then column operation, and then assignment. So step by step let us see how it works. So now in next slide you can see I have done this. I have taken the simplex table of the given same problem, and here now we will proceed with how to apply various steps of Hungarian method. So first is I will move in this direction. First is what we will do is we will perform row operation. The name of step is we will perform row operation. What is to be done in row operation is, what we will be doing, we will be subtracting smallest element of that particular row from all elements of the row, so that we will get 0 in each row. Now here you can see I have drawn a 4 by 4 matrix. Now I will perform row operation. First row, minimum in first row is, as you can see, is 13. So what we will do, we will subtract 13 from all the elements of the same row. So 15 minus 13, it will yield 2. 15 minus 13 will yield 2. 13 minus 13 will yield 0. These are the steps to be carried out under Hungarian method for finding solution to the assignment problem. The first we have checked is whether it is square matrix. Now we are on the second step of whether to perform row and column operation. In row operation, what is the task? We have to bring at least 1 0. I have given everything in my earlier slides in detailed steps. I am now executing those steps. So for this, it is 14 minus 13 is 1. 17 minus 13 is 4. Again I will explain. 13 is minimum. 15 minus 13 leads to 2. 13 minus 13 0. 14 minus 13 is 1. 17 minus 13 is 4. First row operation is over. Now we will execute second row operation. So in second row the minimum is 11. So we will now subtract this 11 from all elements of this particular row. So 11 minus 11 is 0. 12 minus 11 is 1. Got it? Then 15 minus 11 is 4 and 13 minus 11 is 2. So second row operation is over. Third row operation, minimum in third row is, what I will do for your understanding, I will mark the minimum one. So this is minimum, now this is minimum. I have underlined the minimum value for understanding purpose. 13 minus 10 is again 3. 12 minus 10 2. 10 minus 10 0. 11 minus 10 1. Clear? For fourth, minimum is 14. So subtract 14 from all elements of that same row. So it will yield 1. Here it is 3. Here it is 14 minus 14 0. 16 minus 14 2. Now if you recall our steps, what we have written? we have to perform row operation, that is mandatory, to bring 0 in each row. If required, we have to perform column operation. So now one thing is very clear, when we are bringing at least 1 0 in each row, as you can see over here, simultaneously there will be 0 in the column. In some cases it may so happen that if you are performing row operation, you will get 0 in column, all columns also. But suppose while performing row operation, if any column you identify which don't have 0, for that particular column you have to perform column operation in the same manner as you perform row operation. For performing column operation, what you have to do? You have to subtract smallest element of the column from remaining all elements of the column, so that smallest elements minus same element will be 0, and accordingly other values you will get. So we will check whether in this case is it column operations are required or not. So I have now ensured that each row is having 1 0. Now we will check whether column operation is required. So see, for in first column you are having 0, in second column you are also having 0, in third column you are having 0, but see here in fourth column you are not having 0. So now the meaning is you need to perform column operation for this last column in the same fashion. So what we will do? Now I have moved like this. So what I will be doing is I will be moving like this. This is row operation. Now what we will be doing is column operation. What we are doing is column operation. First we did row operation in this step. Now we will be doing column operation. So while doing column operation, again matrix size will be same. Here you have to remember one important aspect, that don't change values of rows and columns where you are having single 0 or at least 1 0. So this 2 0 3 1 need not be disturbed, 0 1 2 3 need not be disturbed, then 1 4 0 0 need not be disturbed. Now here you can see last column it don't have any 0. So what we will do? We will bring at least 1 0. So minimum here is 1. So we will subtract this minimum 1 from all elements of the same column. So 4 minus 1 yield 3, 2 minus 1 yield 1, 1 minus 1 0, 2 minus 1 1. Students, now we are ready for executing assignments, because the essential step is you can start assigning only when all columns are having at least 1 0. At least I am saying there may be more than 1 0. There may be 2, there may be 3, there may be 4, depending on the situation. But before we start assigning, the minimum condition is every column must have, every row must have, and every column must have at least 1 0. So here you can see this is achieved. Now we will proceed for assignment. So how to proceed for assignment? It's very important. Listen now. You have to keep something in your mind, that you have to remember the order of assignment. Here I am writing for your sake as a key. This is key to the assignment problem. Here I am writing some 0, then 2 0, and here I will be writing some important point, rows and column. Now these operations, this key which I am given, first follow it for row, and then follow it for column. That is the meaning. I will explain how to proceed for assignment. So this is referred as single pure independent zero. So you have to start from rows. This is very important. You have to start from rows. Identify rows with first priority. Rows with single pure zero, independent pure zero, and assign that 0. And cross off zeros in related column. I will explain that how to do it. First, ensure this for all rows. Then follow same for column. Then go for this second criteria for rows, then column, and one pure independent with one cut, first for row and second for column. I will explain in this problem. See here, now this particular first row is having one pure independent 0. This second is having only one. But if you look at this is having two pure independent 0. And if you by mistake start assigning from this particular cell, there are great chances of committing lot of mistakes if you are not following the steps. So what are the exact process? This is the key. So start from assigning that 0 which is pure and single. So this is this 0. This is not 6, this is 0. This 0 is pure 0. And the hierarchy you have to maintain, that is rows. As I have written, rows top to bottom. These are the key. Rows top to bottom. Column, if you are talking of column left to right. Follow this key. No chances of committing mistake. When we will be executing row, we will be going from top to bottom. Top means first row, second row, third row, like that. And for columns, left to right. If you assign, remember this is a very important step. If you assign a row, 0 in row, single pure independent 0 in row, and if at the same time there is any 0 in that column where you have assigned 0 of the row, cross of that particular 0 in related column. I am using the word related column because assembly is 1:1. Assembly means assignment is 1:1. One facility to related one facility. You cannot assign one facility to more than one related facility. So it is, since it is 1:1, you have to assign to the respective row and cross off 0 of the corresponding column. What other key? These are the keys I have given to you. What other important aspect you have to keep in mind while solving this such problem is that you have to be very particular that you prevent zeros from crossing. This is very underlined statement, very important underlined statement I am quoting. You prevent, I am again repeating my words, I am again repeating my sentence. While assigning to this matrix, you prevent zeros from being cross off. Zeros from being cross off. How to proceed for that, how to do that will be clear when we solve this problem. So now, as the first step says, start from first row, pure independent 0, assign that 0 and cross off related, from related column any 0 if it is there. See, in the first row I am having this single pure independent 0, I am assigning this like this. Would there have been any 0 in this column, I am required to cross off that 0. Crossing 0 means it is like this. This is cross 0. This is cross 0. If any 0 exists here right now for this situation, I would have crossed it like this. Since there is no 0, there is no need to cross off. Remember, again I am repeating the steps. Keys for all rows and columns. First, pure independent 0. Then second, this criteria, and third, this criteria. Be punctual in that. First row is over, go for second row. Check whether there is only one. Check whether there is only one 0. Yes, only one 0. You can assign. Assign like this. Assign like this. I did assignment. There is no 0 in corresponding column, and therefore there is no need to cross. Now if by mistake, see, now this is a very important problem. If by mistake I forget to apply this key, the key says that you have to first assign to the rows and columns with single pure independent 0. But by chance, if you omit that step, and if you think that you will assign in this third row, what you will do? You will assign here, then you have to cross this 0 also, this 0 also. Means you are moving, you are shifting away from the solution which you may likely get as an optimal solution, and you are creating unnecessary problems in your solution steps. So don't, again I am repeating, don't miss that step. So now I will not allocate in third row. I will switch over to next row, and I will see whether that row is having single pure independent 0. So I am not, right now I am not considering row number 3. I will consider row number 4. Yes, single pure independent 0. So it is my duty now to assign this 0, and it is mandatory for me to cross off this 0. Why? Because it is only 1-to-1 assignment. I cannot assign this contractor number 3 to 2 sub-assemblies. One contractor, one sub-assembly, and therefore I have to cross off this particular 0. Now students, I did row operation for this first single pure 0. What we will do now? Row operations are over. What I have explained as a key, we have to move for next step as column. Since rows are over, I will find the column with single 0. First column is assigned, no single 0. Second column is assigned. In third column also, no single 0. In fourth column, there is one single 0. This one. So, no option other than to assign. See here, these are sub-assemblies 1, 2, 3, 4. These are contractors 1, 2, 3, 4. We can write these contractors as, suppose, instead of giving this as I explained in last lecture, if I rename it as, suppose, A, B, C, D, like this. Let us rub this. A, B, C, T. Now, how to understand There is no need to perform optimality test, because it is obvious from the solution that every row has got and every column has got one assignment. There is no row or there is no column of which 0 is not assigned. So for this 4 by 4 matrix, I got 1, 2, 3, 4 assignment. For this 4 by 4 matrix, I got 1, 2, 3, 4 assignment. And how to interpret the answer? That is very important. So to interpret the answer, now this being the very first problem, for explaining all steps, I have explained how to perform row operation, how to perform column operation, and how to find the solution. If we arrived at this point, how to interpret it is hence assignment is as your sub-assemblies sub-assembly, it is versus contractor. So I will write sub-assembly 1 with contractor, if we name it as B, sub-assembly 2 to contractor A, sub-assembly 3 to contractor D, and sub-assembly 4 to contractor C. This is the fashion way how you have to interpret your result of assignment problem. And minimum total cost, because that is the objective function, minimum total cost Z is equal to, see now what we have to do. For this 1B cost is 1300, 1B cost is 13. So I will be writing 13. 2A cost is 11. 2A cost is 11 plus 11 plus 11 plus 3D cost is 11 plus 4C cost is 14. Remember, this is rupees, but don't forget to multiply by 100, since it is given that the cost items are multiple of 100. So students, for this problem, very first problem, which is asked to solve as the assignment problem of assigning various sub-assemblies to the contractors, we have followed these keys given. These keys are applicable to all assignment problem, and we came with final solution, optimal solution rather, where 1 is assigned to B, 2 is assigned to A. From this table I have written this. And how to find the cost, minimum cost? What I did is, from original given matrix, from original, this is very important word I am using, from original given cost matrix, find what is the cost in that particular cell. Like 1B, in 1B the value is 1300. Why I am saying 1300? Because it is multiple of 100 that is given in numerical. So what I did is, I have picked original cost values of these assigned cells. I have summed up, this is plus sign, this is 13 plus 11 plus 14, sum of this, all sum of this into, since it is given in the numerical problem, it is in hundreds of rupees, I am multiplying, and the unit of cost is rupees. This is how we solve assignment problem. This is very first assignment problem we have solved. and this is the optimal solution for the assignment problem. This is the optimal solution for the assignment problem. Got it? What you have to do is you have to practice similar problems to get confidence. Unless and until this operations research technique is such a subject that only by mere reading or mere finding, seeing the contents, you will not get depth of problem, depth of the steps. You have to solve it personally, variety of problems, then only you will be master in finding solution to the assignment problem. Now we will go for second problem. Logic will be same for all the problems. Logic will be same for all the problems. What is important is, now here in this problem we are not required to find minimum number of lines covering all zeros, and there is no further improvement possible, because the very first solution in this particular problem is optimal solution. But in reality it won't happen so every time. So how to proceed in reality if we are not getting our optimal solution in very first step? That we'll see. So here now, as you can see, this is this was our first problem. This is our second problem, where automobile dealer wishes to put 4 repairmen to 4 different jobs. The repairmen have different skills. What are the important words in the transportation assignment problem that we have to keep in mind? The repairmen have somewhat different skills and exhibit different level of efficiency. Now in this particular case, what is happening? There are 4 jobs. Jobs are named as ABCD. Jobs are given to different operator, which is given in the form of man, as man number 1, man number 2, man number 3, man number 4, and having different skills. And these are the cost. Find the optimal assignment that will result in minimum. These are the not hours. The meaning here is A1A, which is 5 hours. The significance, interpretation of this is, if we are doing job A through man labeled 1, it will need 5 hours. Likewise, suppose I am talking of this 9. If man 2 performs job B, he will need 9 hours. What is asked? Assignment such that optimize problem will give you minimum man hours needed to perform these jobs. Ultimately, what you have to do? You have to perform all job number 1 to A, B, C, D through these 4 mans in such a way that they will have minimum man hours. See that assignment problem may have objective function maximize profit also. What we will be doing if it is maximization type of assignment problem? We will be converting that maximization type of assignment problem into minimization type of problem, as we did in linear programming. We also done there conversion of minimization to maximization. Now here, suppose in a problem objective function or problem defines in a form of maximization. So we have studied the method steps for Hungarian through minimization aspect. We will apply the same steps by converting maximization type of assignment problem into minimization type of assignment problem. Now here, if you recall, very first step is see whether it is square matrix. So it is obvious. Different mans labeled 1, 2, 3, 4, jobs A, B, C, D. So this is very obvious. It is 4 by 4 matrix, square matrix. So no need to add dummy row or dummy column. No need to add, because 4 rows, 4 column. So what is required? What is required? Remember the steps which we have executed in last problem. Can you think? So once you ensure that it is a square matrix, what you have to do? You have to perform row operation. You have to perform column operation. You have to perform row operation, column operation, conditional. Condition is if required. If required. First row operation, if required, column operation. Then third step, carry out assignment. Carry out assignment and check for optimality. If not optimal, then we have to move ahead further. So we'll see for this problem steps one by one. Same problem. What I have done, I have written there. If you see this same matrix, what I did, I have compressed it, I have written it like this. Now we'll be doing a row operation. So if you remember, I'll go in this direction, row operation and column operation. Suppose we go like this, row operation. How to do row operation, that we know. Here I am writing like this, 4 by 4, 4 by 4, first row minimum is 2, so we'll subtract this minimum. This is in unit of hours that we have seen, this 2 from all. So 5 minus 2, 3, 3 minus 2 is 1, 2 minus 2, 0. This is already explained in previous lecture 6, previous slide. So this we have identified here 2 as minimum. Here minimum is again 2. So we'll subtract this 2 from all these. So it will yield 5, 7, 0, and here 4. For third, minimum is 4. 6 minus 4, 2. 4 minus 4, 0. 5 minus 4, 1. 7 minus 4, 3. And for this, minimum is 5 minus 5, 0. 2, 2, 3. So through row operation, what we did is we have brought 0 in each row. Now our duty is to check whether 0 exists in each column or not. First column there is 0, second column there is 0, third column there is 0, but in fourth column there are no 0. So we have to perform. Condition was if required. So yes, column operation is required. Column operation is required, and now we'll execute column operation like this. And if you recall in last slide, I explained that don't change values of the other rows for which there is no need to execute any operation. So it is 3 5 3 5 4 0 1 7 0 2 0 0 1 2. Now here I have to bring 0, so 3 is minimum, so it is 3 1 0 0. We are now very sure that now this is very important step of assignment. So I am rewriting this particular matrix over here. I am rewriting this matrix over here. Understand the steps. This is bigger view. I am rewriting the same matrix to carry out assignment, and the versions are 3 5 4 0 1 7 0 2 0 0 1 2 3 1 0 0. We will check how to proceed for assignment. Very important step. Again recall my keys. Key was 0, first row, then column 0 2 0 1 0 1 cross 0. This is the key which I have given to you in earlier problem. We'll apply the same key. First we have to do this, followed by this. This is first. After columns are over, this is second key which I have given, second, and followed by, if this exhaust, this is our third step. This is our third step. So now let's move. We'll start from first row. Single pure 0. Yes, it is there. Assign immediately. Now you can see here, this is 0 in column. We have to cross this. There are 2 zeros. My rule says that we have to assign with, again I will rub this if it is creating confusion. What is the hierarchy? Single, double, and this is the hierarchy. In hierarchy, first go for individual row, column, like that. So all single pure, first row, then column. If this is exhausted, double 0, row, column. If this is exhausted, one pure independent, one cross, row, column. So this is over. Now here there are 2 zeros, here there are 2 zeros. Will not go. What will go? Will not execute any operation for this row. Will go for column now. And here you can see first column is having single 0. I have to cut this particular 0. I have to cut this particular 0 because 1-to-1 assignment. Again in second, this is one single 0. This is cut. Now here you can see that our problem was man were labeled as 1 2 3 4, jobs were labeled as A B C D. Now we can see that this particular second row right now is not having any assignment, and therefore we are very sure that since man 2 is not assigned any job, it is well understood this is not optimal solution, because for 4x4 I need 4 assignment. Thumb rule: for 3x3 3 assignment, for 6x6 matrix 6 assignment. For 10 by 10 matrix, 10 assignment. 100 by 100 matrix, 100 assignments. Now here for 4 by 4 matrix, only 3 assignment. So definitely this is not optimal solution. But there is one rule which will decide whether this solution is optimal or not. What we have to do? We have to find minimum number of lines covering all zeros, and this aspect with further part we'll study in our next lecture. I will start my this same problem in my next lecture from this point onwards. We have performed row operation, column operation, and we are now on the point of checking whether this solution is optimal or not, and for that condition is we have to draw minimum number of lines covering all zeros. Till that, what you can do is you can try more number of problems up to this particular step, and how to proceed after this step will be dealt in coming lecture. So here today I will stop my lecture, and from again I said from next lecture I will start from this slide onward.